In this video, we are going to be calculating the pH of the resulting solution when the titration has reached equivalence point. Now, just to review, the equivalence point is when the number of moles of acid is equal to the number of moles of base. When we examine our strong acid versus strong base titration curve, we can see that the pH of the solution when it has reached equivalence point is 7. So in our calculations today, we are going to explore why we have a solution that is equal to 7. So in this first titration curve, our example is going to be 100.0 milliliters of a 0.1 molar NaOH solution is added to 100.0 milliliters of a 0.1 molar HCl solution. When we take a look at the equation, we're going to have NaOH plus HCl yields NaCl and H2O. Now, if we take a look at the number of moles, we see that we have 0.01 moles of NaOH, 0.01 mole of HCl. At this point, there is no NaCl produced and there is no water produced. As you can see, the number of moles of NaOH is equal to the number of moles of HCl. As a result, there is no limiting reagent and there is no reagent that is in excess. They will all cancel out or react completely with each other. So we subtract in our change row 0.01 moles of NaOH, subtract 0.01 moles of HCl, and we produce 0.01 mole of NaCl, and we produce 0.01 mole of H2O. Our resulting values are 0 moles of NaOH at the end, 0 moles of HCl at the end. We're going to have 0.01 mole of NaCl and 0.01 mole of H2O. Now, if we examine this first equation, we can cancel out the water. And the reason is that our acid and base are in solution and our solvent is water. And so therefore the amount of water that's produced is going to have a negligible effect on the overall concentrations. We're also going to ignore the NaCl. And the reason why is that Na comes from NaOH, which is a strong base. This means that Na will not want to go to react with anything else to try to become NaOH. And so Na effectively is a spectator ion. Similarly, Cl is also going to do nothing because it comes from HCl, which is a strong acid. So because it comes from the strong acid, the Cl is also going to be a spectator ion because it will not do any kind of reaction or further reaction to try to reform HCl. Now, once we have this, we now can calculate the concentration of NaOH and HCl. But as you can see, there's 0 moles. So effectively, the NaOH, which is essentially the concentration of the OH from the original base, is going to be 0 because it's going to be 0 moles divided by 200 mils. And our answer is 0. Similarly, the HCl is going to give me the concentration of the H+, which is again 0 moles all over 0.2000 liters. And once again, I have a concentration of 0 molarity. Now, if we try to continue to calculate this and we find the pH, which is the negative log of 0, we're going to get basically an error in our calculation because you cannot take the negative log of 0. So the question that we have is then where does the pH of 7 come from? There must be a different reaction that is producing hydronium ions. In this case, the reaction comes from the water itself. What happens here is that the water is going to self-ionize just like what we learned earlier on in this unit. and therefore it is in equilibrium with its H plus ion and the OH minus. And when we take a look, we have an equilibrium, and so we have our ice chart. So we can't do anything with the water. Initial is 0 and 0, then this is plus X, and then this is X and X. Now recall, in terms of the equilibrium of water, the equilibrium constant, Kw, is 1.0 times 10 to the minus 14. Now, if we take a look over here, this is equivalent to H plus times OH minus. So when we now calculate this out, we get 1.0 times 10 to the minus 14 is equal to X squared. So X over here, when we square root it, is equal to 1.0 times 10 to the minus 7 molar, which is equal to the concentration of the H plus. So if we want to find the pH, then we're going to go negative log 1.0 times 10 to the minus 7, and so we end up with 7.00 as our final pH. And so when we take a look at the titration curve, and we take a look at the equivalence point, and we find the pH, and we see that the pH is 7, we now know that that pH 7 comes from the equilibrium that is established by the water.